Well, welcome to AI Decoded. As companies race to develop artificial intelligence at breakneck speed, they are facing a growing challenge. Earth simply doesn't have the resources to sustain the exploding demand for AI-driven data centres. And according to the Financial Times, the race is now on to put such computer infrastructure into orbit. The paper says tech billionaire Elon Musk is making it central to a $1.25 trillion plan to merge SpaceX with xAI. Meanwhile, Google's already made plans of its own to put artificial intelligence data centres into space. With Project Suncatcher, Google has partnered up with commercial space company Planet Labs to launch prototype satellites by early next year. Well, we'll be speaking live to their CEO and co-founder in just a moment. Now, such plans are also backed by the World Economic Forum, who say space data centres no longer a concept confined to science fiction, but are in fact a vital, technically feasible solution that can unlock the next wave of AI progress while drastically minimising our planetary footprint. With me, our regular contributor, Stephanie Hare, co-host of AI Decoded. But before we go to our special guest this evening, let's take a quick look at some of the AI-powered technology currently in space.
Pelican is a next-generation version of our SkySat spacecraft. We took a look at how we wanted to augment our SkySat fleet and make it a little bit bigger and better. But one of the technologies that includes an edge compute platform from Nvidia based on their Jetson architecture. The Jetsons are devices that have a lot of processing power but are pretty low power draw. And it's interesting to us because a Pelican will generate about 1 terabyte of data per day. If we can move some of those computations to the satellite, say by training a model to look for aircraft at airports or ships entering a harbor, we might be able to reduce that to a few megabytes and be able to provide it to a customer really quickly.
So there is the concept AI in space. Let's talk to Will Marshall, who is co-founder and chief executive of Planet Labs, whose company is partnering up with Google to put AI data centers into space. Just talk us through the concept here. Why is space such an attractive proposition?
Fundamentally, compute in space is an idea whose time has come. It's simply putting solar panels in space, for example, you get 5 times more power than you have with the same solar panel on the ground. Why? Because you don't have the day-night cycle, you don't have atmospheric absorption, and so on. That more power can, of course, give continuous power to compute. The only challenge has been historically launch costs were very high, but now launch costs are coming down. And you get, by the way, free cooling from the cold depths of space. So in many ways, it is now getting to on the verge of literally just being cheaper to put it in space. And it takes that energy-intensive infrastructure capability up to space, freeing that land and other resources for the kind of things we need to keep it for, like biodiversity and the environment.
Will, how do you see the idea of data centers in space fitting in with the wider strategy that we're seeing every country and all the big tech companies talking about, which is we need to build out data center infrastructure over the next 10 to 20 years. We don't have enough data centers to make the AI revolution take off. So where does this fit in?
Well, one of the key things that's limiting the scaling out of those compute facilities is energy. The simplest and cheapest way to get energy is, of course, from the sun. The solar panels are now cheaper, but of course, you can't do have a day-night cycle which interrupts your computers. You need them running all the time because people's demand for these AI systems aren't intermittent, they're all the time. And so on the ground, you not only need the solar panels, you need other generations of energy and battery systems or something to keep it running all the time, which makes it hard. So generating power is the rate limiting factor for here on the ground. In space, there's oodles of power, and it was only a question of when it was cheaper to launch it, then this equation makes sense.
Can we also draw on your background as a former scientist at NASA and PhD in physics to talk us through the sustainability part of this story? So we know that data centers require enormous amounts of energy, but they also need a lot of water for cooling. How does that work in space?
Well, you don't have water for cooling, and instead you radiate the energy, dissipate that heat out to the darkness of space. So the background of space is at 4 Kelvin, so you put a radiator out looking at that, and it radiates out the energy. We've been doing that with satellites for many, many years. And so we know how to do the cooling, if you like, for free, just like the energy is sort of for free. You just have to get it all up there. And so that's now, there's a lot of technical challenges, just to be clear. But yeah, in principle, you get that cooling for free. You also, as I said, don't need the land. So the way it fits in with environmental objectives is, back many decades ago, some early thinkers in this, like Isaac Asimov and others, were talking about the fact that ultimately we want to put dirty and energy-intensive infrastructure into space because you want to sort of zone Earth as rural and light urban. Because we want to preserve all the biodiversity, and the thing that's clashing with that is all of our energy use, our resource use, and the more we can take that off Earth, actually it saves that on the Earth.
Will, can I just put one objection that I've read, which is from astronomers who say they're worried that too many satellites in low orbit are like bugs on a windshield when they're trying to look into the universe?
Yeah, I mean, we have to be careful to avoid challenges for astronomers. Yeah, they don't want their streaks through their cameras when they point it up. One of the slight offsets for that, for this kind of mission, is that even though we're talking about lots of satellites, they would be in a particular dawn-dusk orbit, which is basically, and some astronomy is done then, but more astronomy is done at the middle of the night. And so it's less likely to affect most astronomy, but these are real concerns, so they have to be addressed.
And can you talk us through the timelines of when we could expect this to be something that's going to be normalized? When are we going to see data centers in space as a service?
Well, we've already got extensive computers in space. You saw in that little video about Nvidia Jetson processors that we have on our existing satellite. Planet has 200 satellites in space today doing Earth imaging, so cameras looking down, helping us to take care of the Earth. This is swapping those cameras for compute infrastructure. But we know how to build, launch, and operate large numbers of satellites. And frankly, what we're seeing now is, now with this project with Google, we'll be doing this first tech demo of a dedicated satellite just for compute, using their TPUs, the tensor processing units that they developed specially at Google. And they're really efficient for processing AI, doing AI processing. And so we'll be putting the first demo in space within a year or so. But actually getting to scale is going to take, this is an early phase for a moonshot project. It's a long duration project. And I think the right sort of time frame to think about, as Sundar, the CEO of Google, put it, that most data centers will probably be constructed in space in about 10 years' time. So, but first demos in a year, most of compute will probably be constructed in space in 10 years. And in between those things, we'll see a gradual ramp.
And are we thinking of this as largely a US-China phenomenon, or will other countries be able to afford to put data centers in space?
Oh, I think it's totally open to other countries. It's just a question of engineering, skill, obviously resources. I'm talking to you from here in Germany, and there's plenty of capital and engineering talent to do these sorts of things in Europe. It's just a question of will.
Well, thank you very much indeed. Will Marshall there, who's co-founder and CEO of Planet Labs. And Stephanie, just talk us through your views on this. I mean, it sounds like science fiction, doesn't it?
I know. I think for those of us who grew up reading Isaac Asimov and other great writers, to be alive today and to be hearing about this, how it's becoming reality, is fascinating. One of the things that we need to think about is this phase of the AI revolution. So for the next 10 years, data centers will largely be powered by fossil fuels, which is terrible for net zero commitments. It's not a sustainable technology, AI, in any way. But the idea that within 10, 20, 30 years, we'll have renewables, nuclear, and potentially have them up, data centers up in space, that's a game changer. We could really rethink about how we want to steward Earth in regards to its relationship with us and technology.
Do you think then it's a good thing, this whole idea of data centers in space?
I'm very open to the idea, and I would like to see more. Yes, I'm intrigued.
I think we're all pretty intrigued, Stephanie. Thank you very much, as ever. And that is it from AI Decoded for now, but you can catch up with the long-form AI Decoded weekly programme on BBC iPlayer, as well as the BBC AI Decoded playlist on YouTube. And if you'd like to get into contact with the show, do please email aidecoded@bbc.co.uk. Thank you very much for watching.